Victoria, as my team calls me, or Victoria Funk from Team 21-7 TORC, and this is our certification system for our fabrication shop. Our machine shop was fully paid for by Oxford Public Schools, and in 2012, one of Kettering's faculty, Dan McCara, came to our facility and trained our mentors on how to properly use machines. We videotaped it and have posted it on our YouTube channel. During the training, student members are trained, preferably one-on-one by an authorized person, either a level 4 student or mentor, and I'll explain how that works later. And it's to ensure the safety of the student and the skill they learn and use on the machines in the shop. All that will be explained later too. The certification training, there's 5 different levels. One of them is just for everyone on the team has to pass it, or they don't even get to go in or near the shop. It's for their own safety precautions. Level 1 is trained, where they demonstrate the knowledge of and basic safety procedures and know the basic use. Level 2, they're observed to go on to that level, and they know they have a better ability of using the machines, like slightly more advanced. They can change the speed, other settings, and can follow a CAD printout with certain tolerances. At level 3, they refine their skills by doing more advanced operations, having a CAD drawing with no tolerance. They have to completely fabricate that in order to pass it, and then at level 4 they have to actually create a procedure, and at level 4 you're able to teach a student up to level 2. For level 0, I like to call them Jar Jar Binks, because why not make this fun with Star Wars? This is basic safety, where they're given a 5-question test. They have to get an 80% to pass, and it's with basic safety knowledge that everyone on your team should know. I have everyone on my team take it. That would be your own choice. And if you don't pass, you don't get to enter the fabrication shop.
So, what kind of questions are on the test?
If you flip to the last page of the packet I gave you, I'll
Okay.
also bring it up on the screen later.
Okay.
Those are the 5 questions I gave to my team.
Thank you.
At level 1, they are actually trained on the machines, because not everyone wants to fabricate. They know the safety procedures, the personal protective equipment they have to wear on the machine or in the shop. They know the basic operation of it, and they can accurately use the measuring devices given to them for that machine. Level 1 students may only work under the guidance of a mentor or level 4 student. At level 2, they are observed during this process for the test to go up. Their mentor just stands by them, watches them working the machine. They're able to read and understand the CAD drawing given to them, with a few tolerances they have to follow, and they must work with the mentor present in the shop if they're at a level 2. At level 3, they refine their skills, and your packet also gives examples like installation and use of a 4-jaw chuck on the lathe, or proper adjustment of the arc balance on the TIG welder for aluminum welding. Those kind of advanced operations they have to do. And it's a CAD drawing. They have no tolerance, so they have to get it exact. They work alone while the mentor is just standing there watching them, so a little bit of pressure. But they may work while the mentor is in the facility. They can operate machines in a fab shop. At level 4, there's actually 9 steps they have to do this. All of the sign-offs have just one sign-off. This one has 9 different steps they have to go through. The fabrication mentor gives them a certain procedure they have to do on the machine they want to be certified to a level 4 in order to teach students up to level 2. And if you read through those, you can see the steps they have to take. Like, they have to research it and then make a procedure, give it to the mentor reviews it, gives it back to them. Then the student has to make a video and take pictures of themselves doing it, and then has another student doing it, and then putting it on a fabrication drive or the Google Drive, which we have made so other team members can see it and learn that procedure.
So is there a timing system on this, or is it
They
work at their own pace?
They can work at their own pace because everyone has other responsibilities they have to go through. But we estimate about 2 weeks with a non-busy schedule, as in not build season.
Okay, I have a question. When you say they have to report themselves on machines, is that right?
Yes, they can have someone else videotaping them or taking pictures of themselves doing their own procedure. Like they have to take notes of themselves going through on improvements they can make for the procedure. We're going to bring up the actual equipment proficiency sheet that we use for level 1, 2, and then on the second page is 3 and 4. At level 1, it lists all of the requirements they have to do, like students to wear personal protective equipment, the proper guards, everything like that. Level 2, I already explained all this, demonstrates and explains how to use equipment properly. Student can read CAD, prints data, everything like that. So this is what we use to make sure the student passes the level, and if they don't meet one of them, they'll have to schedule another time to do it again. Each student gets this for each certain machine, and then later on we put it into an actual file, which is on our Google Drive. Like that's the entire summary of what he can do on what machines according to this certification system. If we were using last year's, he'd be level 4 on all the machines. This is our fabrication captain. Then and if we scroll over, you can see each of the machine names. Kelly? What? No, the scroll arrow. This one. That one. Scroll over. You can see that there's the different machines and what they use on, certified, and whatnot. That one.
She's working with an inept.
That one. And then this has the student names at the top, and then the machines, and you can see who's certified on what. Each level is a different color, and same thing with the box for higher levels. And then for everyone else that didn't see it, this is the basic safety quiz.
Do you have that spreadsheet displayed anywhere?
I have the link to it on our website, but I heard there were some difficulties with it, so I'm going to talk to our website team, try to see if we can figure that out. This is the basic safety quiz that you guys didn't see, that we have everyone take. I had them take it after my kickoff safety presentation, because all the answers were literally given in the presentation. I even had them underlined, yet there were still people that failed the first time through. Like PPE is important, what to wear, what not to wear. We have lines in the shop, yellow lines around the machines, so everyone knows the work area, red for knowing what areas not to go through, and then blue is just for safety glasses and food needed. And then they have to answer, while in work areas, why is it still important to be aware of what's going on, even if you're in a safe zone or untaped area. And then the last question is, that's not the page. Last question is, why is it important to clamp down your piece when using tools and machines? Because we sadly have our mill right by the door, so our students need to make sure their pieces are clamped down and there's not a chuck in it, or else something will fly out the door and possibly hurt someone not paying attention.
Sorry I'm late, but I made you some copies.
It's okay.
There's extra copies here.
Any questions?
Yes, I have a question. When do you start your training? Do you start it right after the 6 weeks or before that?
Sometimes we have it during the 6 weeks if we're low on fabricators and we know we're going to need some, depending on, but preferably we have it during our off season or competition season. Like, we still meet throughout the summer and we meet throughout the beginning of the school year. I organized, we met on Thursdays during the first semester. I organized on Tuesdays where kids could come in to learn more about SolidWorks for CADing, or could actually come in and get more proficient at the machines in the shop.
I think you had 9 weeks of fab training this year.
Maybe. I didn't keep track.
So are you doing it in the fall too?
That was first semester, so yes,
Right.
we do it in the fall, we do it in the summer, and a little bit during the competition
Okay.
season, but very little during build season because of how busy it
Right.
gets.
Is Is there a preference between SolidWorks and Inventor?
We actually had my dad put together a presentation to the mentors. We preferably use Inventor for now. We're trying to go on to SolidWorks because Inventor is not widely used in the real world or real world job businesses.
Okay.
But we use Inventor because our students learn it through the PLTW programs in our school. So for now we're using Inventor, but over the summer we've been teaching SolidWorks because you can also take a test and say I'm certified this way in SolidWorks through that certification test and present it to businesses.
Does SolidWorks work well with the kids? Is it something easy they can pick up, or?
If they know Inventor, they should be able to pick up SolidWorks pretty easily, I've heard. I tried it a little, but I've never been the best with CAD modeling.
What about Inventor? Is that pretty easy for your kids to pick up? Something?
Inventor is a very basic CAD program. That's why a lot of places use it. Like the college I'm planning on going to uses it because it's so easy and it's not exactly the most expensive.
Is it possible I can get a copy of that spreadsheet right there?
I can send you the link.
Email it to me?
Yeah.
Thank you.
Anything else?
Well, you guys are very fortunate to have the machine shop you have. I mean, it's awesome, quite frankly. Most high schools would be very envious of that.
Might tell them what we're currently investigating for next year with the badges.
Oh, for our sign-in, we usually had just the sheet with the scan where you sign in with that. Next year, we're hoping to have actual badges like you do at businesses where you have to do that to get into the building. We're going to have badges that students are going to use to sign in, but it's also going to hold their certification settings on there. So you can just scan it, see what level they are for what machine, or if they're even a level 0 to enter in the shop.
Yeah, so our machine shop we have a badging system in place, but we're not quite sophisticated to do that quite yet. But the mentor this term, because we just started in January, the mentors were trained on the machines, so they have to badge the students in. But the students get to work on the machines while the mentors are standing there watching them. But we want to move towards this certification process. That's why I want to see this today, because this is exactly where we need to move to.
Hi, I'm Devin King. I'm going to teach you a little bit about the safety of our lathe. So first, to start off, we normally take and turn on the main breaker, and then the lathe breaker, and then the emergency switch has to be flipped on as well. So there's 3 points at any time you can take and turn off this machine. To start off, we'll put in a piece of material inside of here to make sure it gets locked down nice and tight. We'll check all 3 of the points of contact of this vise because they don't all close at the same rate. So then what we're going to take and we're going to throw down this the protective shield and put in our tool bit. This, we have a quick locking tool bit, so you just take and swing it around and it locks into place. Whenever you turn on this machine down, it makes the piece go in the reverse direction. Meanwhile, up makes the piece go in the correct direction. In order to turn the machine off at any time, you can take and just take a step on the brake, and as you can see, it's still engaged, but it won't turn back on until you flip it back into the engaged position. We'll take off about 50,000ths inch of the material at a time to ensure that we get a precision cut. And in order to turn off the machine for the day, we take and lift this up, undo the tool bit, turn off the lathe to take out a piece, and then you take and turn off the main breaker as well as the lathe breaker.
Okay. All right, go.
Hi, I'm Devin King. I'm going to teach you guys a little bit about the drill press today and safety. Probably the first thing that we should talk about is just making sure that extra material and scrap metal is taken out of the grooves of here to ensure that you get a precision cut. Next we take and we'll slide the drill bit right up into here, and we can hand tighten it in the chuck until we use our chuck key to take and tighten down in all 3 locations. We then have a vise that can take and be moved around this entire table and clamps all sorts of different varieties of material. And we take and we manually clamp these in so that they don't move anywhere. And then to turn this on, you just hit this green start key. Turns it on, and then to stop it, you just hit the red one. The red one's a lot easier to press than the green one is because safety is number 1. In order to take out the drill bit, you do just the same steps you do to put it in, however in reverse. You spin it to the left, and the chuck unwinds while the drill bit is right here. You can take and magnet that right back up there. And you can clean out any remaining pieces from your. Hello, I'm Devin King, and today I'm going to teach you guys a little bit about the cold saw. Normally, we would take and to start off, we would first take and brush off this machine. However, with this machine, we use cutting fluid, and so that takes and it prevents us from being able to clean out all these little metal chips on a daily basis. However, at the end of the season, we take a shop vac and we clean this all up, take paper towel and rags, and we clean it all to pristine new condition. To start off with this machine, there's a on and off switch from right here. You take and you pull it up to turn it on, and so it's easy to turn it off if you were to have a mishap. Whenever you first secure a piece of stock in here, we try to use these diagonal vise pieces in here because it prevents moving around in any direction, unlike with the traditional vise, which grips on only the X and Y direction. To take and run this machine, there's a button press up here. It takes and releases some cutting fluid, and that helps aid with the cutting to help cut through steel, aluminum, and titanium like butter. However, as you may have noticed, the machine will turn off if you do not hold this button press the entire time. So that's another safety feature that's added into here, so that if you ever were to let go, it will not ever turn back on unless you take and hold up the entire machine back to its original location and then back down to restart. To take and turn off this machine for the day, we just take and push this down.
There you go.
Hi, I'm Devin King. Today I'm going to teach you guys about the vertical bandsaw. Typically when we start out, we're going to take and brush off all the remaining pieces so we can get a nice precision cut. And then we'll start by turning on the switch into the off position, as well as hitting the on button to turn on this machine. However, we use a safety stop of this wood block right here so that we can prevent our hands from getting ever too close to the blade. So we'll take and turn on the machine with the on button, and then you'll take and push a piece of material into this blade. And then whenever it gets into the wood block, you'll take and just pull it right back out, turn it off, put it back here, grab your brush, and clean off the machine as well as flicking off the switch.
Okay, go.
Hi, I'm Devin King. Today I'm going to be teaching you guys a little bit about the mill and the safety precautions that go along with it. Just first start off, we're going to walk over here to the main breaker, and we're going to put it to the on position. Next, we're going to take and open up the vise and make sure that we get all of the pieces of material that may have been left from a previous breaker. We use a small paintbrush because it helps get in the crevices of the mill. Then we're going to take and put parallels in here. They're perfectly made on each side to help us with the precision of machinery. You don't want to have any chips underneath of it, otherwise your parallels will not won't be able to mill a parallel surface. Place a piece of material in here. We're just going to use this device. We're going to clamp it down. Take and push and clamp at the same time, and then clamp down all the way. Today, for this instance, we're going to be using a 3/4 inch collar as well as a 3/4 inch end mill. To put that in, you're going to take and we're going to put this up into here. There's actually grooves in which it goes into, so you have to kind of feel around for the groove, and then it slides up into there. You're going to take, and there's a screw on the top, and you're just going to screw it down until it can no longer be hand tightened. Then you're going to slide the 3/4 inch end mill into the desired location. Hand tighten it down so it doesn't tighten anymore. There's a brake on the left side of this machine that will prevent the rotating head from moving at all. And you can use that to your advantage to help you tighten down this machine. So then we have a 3-axis readout here, and as I change each direction, the numbers change, and that helps us with precision all the way down to the 10,000th of an inch in all 3 axes. So once you get it to the desired location, you can take and turn on the machine by using the forward arm. You can only change the speed of the machine while it's on. We tend to keep it around 1240 RPM for standard aluminum milling. That was in high gear. However, if you were to switch it to low gear, you actually have to take and rotate the head until it clicks into low gear. Just like that. Now, whenever you take and turn it on, you can't do that while it's turned on, otherwise you'll grind the gears and ruin the mill. But now, instead of having to go in the forward direction, you can actually flip it to reverse, and it's opposite of what it used to be. So now it's going to be moving real slow, and you can adjust the speed just as you did whenever it was in the high gear. There's a brake over here so you can stop the bit from rolling around, and you can flip it back to high gear and make sure it goes there. You can, we have a handle that's just like the drill press, and we have an auto feed which will take and help us feed. We can set how far you want this to go up, and it will automatically feed down. To a certain point, this will disengage and it'll come right back. Hi, I'm Devin Kane. I'm going to teach you a little bit about our 2 belt sanders. First, to start this machine, you're going to take and flip it to the on position. At that point in time, you can take and clean off the machine for any leftover aluminum or steel dust. Then we're going to take our 90-degree block, which will help us get a 90-degree angle on certain pieces. However, for today, I'm just going to be taking off the sharp edge on this material. So to start, you're going to take and you're going to engage this to the start position. It takes a lot of effort because safety is number 1. So first, we'll start off and only use the point that keeps downward. You only point the piece downwards because if you were to point it upwards, it will grab onto the sandpaper and throw your hand down into the vise. To turn this machine off, the stop button, it's really easy to press. You just tap it and it turns right off. Then whenever you're done with the machine for the day, you'll take and clean off any remaining material that you may have had, re-engage this to the correct position, and then turn off the main breaker.